Neat thing about polynomials, you guys can make polynomials and you can make them have however many zeros you want. Like for example, I can make a polynomial that has these zeros, -2, 5, and I don't know, 37. That would make some really nasty numbers, but I'm trying to keep it simple, so I'm just gonna say 2. Okay, now the fundamental theorem of algebra says you could take any polynomial and you could rewrite it into factors, and it would be in this form: x minus your 0, x minus your 0, x minus your 0, so on and so forth. You could have, however many factors you want. We'll say this is 1, this is a second k, this is a 3. These are zeros. These k's there are zeros. And so if you know your zeros are -2, 5, and 2, you can write x. Well, what kind of factor would give you a -2?
+2.
It'd be +2, right? Which is actually x minus -2. So it would fit this form, but we wouldn't write x minus -2. We would write x plus 2, like what you guys said. And then you have x minus 5, and then x minus 2 to get your last one. Okay, so if I multiply all these together, then I will get a polynomial, and I would satisfy this first one. Let me show you really quick. I'm actually going to multiply this first one to the last one first, because that's a difference of squares, and I like that. So it would be x squared minus 4. And then I have to multiply it times x minus 5. So I multiply that out. I get x to the third minus 5x squared minus 4x. And then plus 20. There you have it. This would satisfy the first one, and that's what you would write on one side of your little strip that I gave you guys. Copy that? You guys got that? That's okay. So that's doing this one. You have to have at least 3 to 5 zeros. Okay, I chose 3 right here and just showed you guys how you could make it. So there's your polynomial in standard form. That would go on one side. On the other side, you gotta make a gnarly one, a scary, gnarly, nasty one. Okay, by using one of these. You can use fractions, you can use square roots, or you can use complex numbers.
Only one of them, or?
You can use a combination of them, or just one of them. Okay, but just be careful. I'm warning you, it will get nasty. It will get nasty. So like, for fractions, I don't think I need to show you guys fractions. Let's show square roots. If you guys chose like square root of 5 as one of your zeros, try to choose also choose negative square root of 5, because then when you multiply it all out, it'll come out pretty. Okay, and then like throw another number in there or whatever. So this would be x minus square root of 5, x plus square root of 5, and then x minus 3. Oh, I don't care you showing your work. I just care that it's correct.
So
yeah,
you just want the equation.
I just want the final result. Yeah. So I would just multiply this out, and then whatever my result is, multiply it to that, and there's your trinomial. Okay. Now, what about these complex numbers? Ooh. These ones would be the nastiest looking ones. When you're finished, they won't look as nasty, but they are nasty. So like if you did a complex number, let's say 1 plus the square root of 2i. That's what makes it complex. You have an imaginary part. That's one of my zeros. You want to make sure the other one is the conjugate of that. So change the sign on one of the terms. I like changing the sign on the imaginary part. And then I'm going to throw in a -3. So if I wanted to find my polynomial that had these in there, actually I'm also going to put in a +3. Yeah, that'll be fun. Okay, so we have x minus 1 plus square root of 2i times x minus 1 minus square root of 2i. And then you have x plus 3, x minus 3. There you have it. Okay, so I got 4 factors right here. You guys all tracking? And you have to multiply this out. It's neat because it cleans itself up. Like, it looks nasty right now, but it'll clean itself up once you once you start multiplying stuff out. Now, so far I've shown you only zeros with a multiplicity of 1. You could make one that has a multiplicity that's higher than 1. Like, I could put 2 3s in this. So 1, 2, 3, 4. It would have 4 terms right there. So I also need to have another x minus 3. You do that. That's kind of neat because it makes the graph bounce off of the 3. All right? Yeah? So there you go. That's how you guys are going to make your scary polynomials. There's only 2 that you guys have to make. One that has 3 to 5 zeros and one that's scary, gnarly, nasty. Using one of these. That's how you're going to make him look nasty. Scary. Can you use what? Multiple?
Yeah.
What does that mean?
Multiple.
Yeah, well, and like, yes. You can use multiples. You can have fractions and complex numbers if you want to make them look nasty. Also, don't forget about some of the cool tricks, like a difference of squares. If you took x plus 1 and x minus 1, those are really easy to multiply because, you just have to square the first and the second term and subtract them. Do you guys remember these? Like this guy right here? Yeah. You can use difference of cubes too, but the problem with using difference of cubes is you also have to find the zeros that it makes. And so you'll have to factor this and find the zeros that it makes. This one has imaginary terms in it a lot of the times.